All right, so anyway, Boyle's law, there are many laws. Boyle's law, the one that you got to know is this. All right, and I'm going to give you a formula sheet later, but you need to go ahead and write this down. It is P1 equals V1, P1 times V1 gives you P2 times V2. So what do the 1 and the 2's mean? Well, beginning, end. Okay, if you want to change that to like I and F, that's fine too. Initial, final. This only works if you keep temperature constant, like one temperature. Doesn't matter the temperature as long as you keep it the same. Also, you got to keep the amount the same. Then you can see his law actually demonstrate. This works like this. Okay, you'll see it if you actually plotted it. If pressure goes up, what happens to volume? Well, read here. Pressure and volume are inversely proportional.
So as pressure increases, volume decreases.
Okay, the word inverse means opposite will happen. So this is one reason why this helps you on your ACT. The word inverse, this has an inverse relationship. Inverse means opposite. That means if one goes up, the other goes down. Okay? If the other goes up, what happens to the other guy?
Goes down.
That's it. By the way, this is the only law that's inverse. Say that again. This is the only law that's inverse. Okay? So, by the way, look at the formula. You'll notice when I give you the whole formula sheet, that is the only formula that is that looks like this. All the others are in fraction form. Okay? So, that's how a little graph would actually look. Now, I'm going to show you like how the little graph curves and everything. Let me jump back for a second. How to help you on your ACT. Okay? Without reading the question, and they give you a graph. You've seen the graphs before, right? Okay? This is going to help you on your test, too. If you see a curve like this, okay? Some people call it an elbow shape. I call it a butt shape. Okay? A butt shape. That's how I memorize things. If you see a butt-shaped curve, all right, like it's sitting down, like someone's sitting on the corner here, that's an inverse relationship. No, not like that, okay? But imagine a chair, and you're sitting in it. Inverse relationship is a curve like this, all right? I'm going to jump ahead. Then what does a direct look like, do you think? If this is inverse, what does direct look like?
Opposite.
Okay? Some people think it is going to be not a curve, it'll be a line like that. It's actually a line, but it's not this. It's this. So this is direct, and that's indirect. In other words, same as one goes up, the other goes up. As one goes up here, the other goes down. Opposite. And you were actually supposed to know all that before you got out of middle school. Knowing these two things is like a quick hint on your ACT in your science portion. Knowing just that relates to everything. What if I told you that that is the main thing you got to know for your ACT, for science portion? Like that will make your score go up 5 points.
Really?
Yeah. Just knowing that, because every graph is either going to be presented as indirect or direct.
Oh, good. I needed 5 more points.
It really is. Every graph is. They can change this and do a bar graph and show you like one up here and then it comes down and it does something weird. It doesn't have to be a line graph, but they're all the same thing. We use line graphs because they're easier to read. What is the pressure at right here?
1.
1. Okay. What's that over here?
2.
Okay. Did the pressure go up?
Yeah.
Okay. So the pressure increases. We know that. Look at our temperature. 300. What's it at over here?
300.
300. Did it change?
No.
No. Kept constant. Okay. So only thing that's changed so far is your pressure. All right. Let's look at our volume. All right. Where's it at?
It's up here.
Okay. Now where's it at?
Down there. Down there.
So it was 4 and now it's 2. Did it go up or go down?
Down. Down.
So what happened to pressure?
It increased.
What happened to volume?
It decreased.
Is that an inverse or direct?
Inverse.
There you go. That's why it makes the curve that you see there. That's what they basically mean. As one goes up, the other goes down. Indirect relationship. Notice the amount was stayed the same. That's what that little picture stands for. But basically, that's the difference between the two. Like I said, I'm pointing these arrows here to help you out. So how is this formula true? Okay, well, let's plug it in. Boyle's law was P1 V1 give you a P2 V2?
Correct.
Uh-huh. All right, so these are P1 and V1. Okay, what's the pressure at?
4.
That's the volume.
Oh, 1.
Pressure is at 1.
All right. So at 1 ATM. What's your volume at?
4.
Okay.
Equals 4.
Now we move over. All right. What's our pressure at now?
2.
Okay. What's our volume at? 2. So are those equal to each other?
Yes.
Yeah.
1 times 4.
4.
2 times 2.
4.
They're equal, which means that's why it's a law. Okay, so how are you going to use this in class? Well, let's say I said blah, 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 that you did not know the volume. If I said I have a container at 1 ATM and that's 4 liters, and then I said I increase the pressure to 2 ATM, what will my volume be? All right, solve for X.
You just find what
Yeah.
you would have to.
So multiply these two, you get 4 ATM dot liters. Got to keep the units. That'll be just 2 ATM X. So what do you else do? You just said it. 2 ATM on both sides.
Cancel out. And you level
What cancels out here when you divide?
the 4 ATMs. The ATM.
The ATM cancel out. 2 will go into 4 how many times?
2.
Oh, I mean,
And you're going to be looking at 2L equals X.
so you plug that in.
Yeah.
This is just algebra. That's all this is.
Simple, man. Simple.
Yeah. So if I change these units up a little bit, obviously my answer is going to be a little bit different. But that's why the law works. It's an inverse. It's a inverse, or I'm sorry, indirect proportion. So as one goes up, the other goes down. By the way, look at it. Did the volume go down? Did the pressure go up?
Yeah.
That's how they work out.
Uh-huh.
So let's go through all these. As pressure increases, what happens to volume?
Decrease.
It decreases. As pressure decreases, what's going to happen to volume?
Increase.
Increase. I'm going to tell y'all, and I see people do this on the test all the time. It's okay if you do this. Use your hands. Okay? If pressure goes up, what's going to happen to volume?
Down.
Don't try to get, sometimes visually it helps. If volume increases, what's going to happen to pressure?
It's decreased.
It's going to decrease. They're all inverse. As one goes up, the other goes down. This is the only law in this unit where they're opposite. Everything else is direct. That shouldn't be hard to remember. All right, so here's the thing. P1 and P2 have to have the same unit. All right, V1 and V2 have to have the same unit. In other words, this would not cancel out if I didn't have them both in ATM. If I had ATM and Torr, I either have to make them both Torr or both ATM. That's the catch in this unit. I know you can plug them in. That's great. People don't have problems plugging them in. They have a problem with not checking their units to make sure they cancel out. So for example, if I had, I don't know, 800 Torr here, I couldn't solve because that's still an ATM. I'd have to make them both the same unit. That's the only other issue. And it's not hard. As long as you memorize that, you're fine.
Yeah.
All right, so first example. Let's try to work this one out. This one's not so bad. They do get a little bit trickier. There'll be a little bit of conversions in there. All right, so for example, a balloon filled with helium has a pressure of 1.2 ATM, okay, and a volume of 3.2 liters, okay? What is the pressure if the volume is decreased to 2.8 liters? Guess what? I don't know if you've done this, but I'm going to do it old baby algebra way, okay, which is list out all your units. List out who is what and what is where. Now, some people have the biggest problem with this, and it's really easy to fix. They're like, well, I see 2 volumes and 1 pressure. How do I know what volume goes into which one? Is that my V1 or V2? All right, I'll go ahead and give you a hint how the formula works. It really just depends on how they write it in the sentence, okay? If they say 1.2 pressure, okay, and a volume of 3.2 liters, they're both your 1, okay, or your 2. It doesn't matter. It will still work out. But as long as these two guys are on the same side of the equation, you're fine. But if you did 1.2 plugged in with 2.8, it wouldn't work out because that's not what they're asking. They're saying initially you have this, P1, V1, okay? What is the P2 if your V2 is this? That's how you should be able to read it. You should not read words. You should be seeing a formula pop up in your head. And if you're not, then you're totally missing the concept. All right, so this is how I would do it as beginner. Actually, I still do this. So what I do is I do like my old algebra teacher taught me, list everything down before you plug it in. I know it wastes time and it doesn't help you on the ACT, but for this, I'm just going to do it this way. So what was the first pressure they gave you?
1.2.
Don't forget your unit with it, please. Then the next guy said, and a volume of 3.2 liters. Now, I can't tell you this, but you got to know like before and after. And that's all what the 1 and 2 means, before and after. Before it was these two guys, after it's these two. They won't always be left to right in a sentence. You got to actually kind of think, okay, both of them are here. What is it after? We are looking for our P2. Okay? And, but they did give us our V2. And there's everything you need to know. Now all you need is your formula. Okay? And again, you don't have to memorize this formula because I'll be giving you a formula chart. You just got to know how to plug the joker in. So guess what? You take all that and plug it into the variables. And then you solve for the missing guy. So 1.2 goes here. All right, now you don't have to put the units when you plug it in if they are the same. Actually, let me jump back for a second. First off, are these two the same unit?
Yeah.
That's good. You can move forward and plug it in. I should have told you that before I moved on.
Thank you.
If this was in milliliters and that was in liters, you either got to make them both milliliters or both liters. It doesn't matter which one. They're going to cancel out. But you got to make them the same unit. Okay? Otherwise, you got no hope. Okay. So looking at this, you got 1.37 ATM. How do I know it's going to be an ATM? Well, what unit would be left over? These two would cancel out.
ATM.
ATM. So that's pretty much how it all works out. Okay, that was not too bad. A hot air balloon has a pressure of 932 millimeters of mercury and a volume of 5,333 liters. Okay, now this is a big balloon, by the way. If you didn't notice, it's the huge one. It's not a little tiny one. What is the new volume if the pressure has increased to 274 kPa? First off, let's go ahead and list things down. Okay, what is this?
P1.
All right, that is a P. Well, let's call it P1. It says and a volume. These two are linked if you see and or at. That means they're saying they're both on the same side of the equation. That's a good key way if you're like getting lost. Which one do I know is the one and all that? And at, that kind of thing. If they're in the same sentence, they're probably going to be on the same side of the equation. So that's our P1. This right here is going to be, is this a volume? Yes. That's our V1. So you don't have to list them out like this. I see some students going in, they highlight on the question and they write down P1, V1 so they don't have to go back and do this. But however, I like listing out to the side so I know that the units match. For example, what is the new volume? Well, guess what? There's your V2. You're trying to solve for it. If the pressure increases to 274 kappa, or kPa, kilopascals. All right, so here's the problem.
Kilopascals.
We have 932. Okay, you have 5,333 liters. I think they just made that up. We don't know our V2, but our pressure is at 274 kPa. Some of you are like, well, I'll just plug it in the equation now. If you did that, what's wrong? These two are pressure, but they are not the same unit. Okay, so you're like, well, what do I convert it to? All right, there's many things you can do, but the most simplest thing is to pick one and turn it to the other guy. Okay, so like turn this to kPa or turn this into millimeters of mercury. So it's your choice. Pick one. Which one do you want to convert? kPa to millimeters of mercury. All right, so we need our ratios over there. Let's start out with 274 kPa. All right, so you look at your ratios. Actually 101.325. And that equals how many milliliters of mercury? 760. All right, so kPa cancels out. Multiply, cross, and divide, you're going to end up with a weird looking number. It's going to be probably a little large. 2,500?
No. 2,055.
55. 0.17 millimeters of mercury. Now notice what I did. I go back and I crossed this one out and I said this is the new pressure. They are the same thing. Okay, I want y'all to understand that. It's just I converted it over to another unit. Yes, I know it's pointless. Why don't we all just use one pressure? Well, we all don't live in a perfect world. So are these units now the same? Yes, they are. You got liters. What's your unit going to be whenever you do solve for the volume?
Liters.
It's going to be in liters. So let's plug her in. There we go. So what is our V2? You're multiplying these two and then dividing by this.
2,418.46.
400?
Yep, 18.
Oh.
36?
46.
46. Oh well. And again, what happens if you forget your unit?
Whole thing's messed up.
Yep, it's wrong.
You're wrong.
You're wrong.
You're wrong.
So please don't forget your units. This one is not hard to forget. Remember the units. Yeah, that's pretty much the only hard part with dealing with pressure, is having to convert them. That's it. So as long as that's the one part people screw up on tests. They forget to make them the same unit. All right, so what volume in liters will a sample of nitrogen gas occupy at standard pressure if it occupies a volume of 380 milliliters of pressure at 730 torr? Okay, so real quick, let me zip-zap through this real fast. You're looking for volume, okay? You can say this is your V1 or your V2. It does not matter. The main thing is that you realize that these two guys have to be, these two guys have to be on the same side of the formula. Why? Well, I'm saying this at this pressure. That either has to be both my 1 or my 2. Okay, it's up to you. Which one you want to be? You want to be your 2? 1? I don't know. Let's go with 2 since it's listed second. And that's your P2. All right, so this then will be our V1 that we're going to solve for. But however, they don't give you another number for pressure. What you going to do?
You gotta use the at standard pressure, which is 22.4.
A lot of people go for the 22.4 thing, but that's only if you have a constant mass being involved. So that's how we know with that. It really depends on what kind of, or how much moles of gas. So do you see moles of gas involved in here? No. So that's one reason why we can't do the 22.4. I'm glad y'all know that, but I'll show you where we got the 22.4 liters later. But I will tell you, you're not going to use that 22.4 in this unit. So that's the good news. I know you did it last unit. Yeah, the only thing I can tell you is it's background story here. So we're going to do a prequel here. So how do you figure this out? Well, yesterday I told you the one thing you do got to know for the test that I'm not going to give you. You got to know standard pressure and standard temperature. So look back at your notes if you forgot what that was. Those are the two things you got to memorize. That's the one thing students miss on the test. And it's the most easiest thing to remember. What is a standard pressure? 1 ATM.
Yeah, I got it right.
And then what, just for craps and giggles, if they said, what is standard temperature?
273.
Okay.
Kelvin.
Both of these are standard temperature and pressure, STP. Okay? You can use either one. They might say STP. They might just say standard pressure or standard temperature. They will not ask you for standard volume. If they did ask you for standard volume, then they would say 22.4, but I'm not going to ask you that on the test. So that's one less thing you got to actually remember. So when they say standard pressure, they say 1 ATM. You're going to get a lot of questions like that. And I'm going to have people come by and ask, well, I don't know where to get that value. You have to know it. You have to know it.
I know it.
You got to know it. So here's a quick trick. You can convert that 730 torr into ATM and have two of the same units. Or if 1 ATM is standard pressure, then are all these units standard pressure also? Yeah, so make it easier on yourself. Just find the one that matches this, 760 torr. So instead of using 1 ATM, just use 760 torr. Basically what I did was convert 1 ATM, which is standard pressure, if you want to see the math behind it, torr. But those will cancel out and you're left in 760 torr. It is going to be this right here. So that's going to be, what is this going to be? Well, we already got our P2, so that's got to be our P1. So all you got to do now is just plug it in, guys. Now, however, what is your volume going to be when you do answer this?
Milliliters.
Ah, milliliters.
Liters.
No, they want it in liters, but if you plug this in your formula, it's going to be in that. So for example, you got P1, V1 gives you P2, V2. All right, we're solving for our V1. Okay, so let's plug in everything else. We know this is our 760. We got to find V1. P2, 730 Torr. And then we got 380 milliliters. They want it in liters. Okay, you have two options here. You can go ahead and convert that milliliters into liters, and then you plug it in and your answer is in liters. Or you can convert it after.
Do it after.
One way or another, you got to do it. What you want to do, before or after? Do it after? All right. So it's where I got this plugged in. This answer will be in milliliters. So basically, this times this divided by 760. You could convert this using the ratio that 1 liter, I'm sorry, what am I doing? 1 liter equals 1,000 milliliters. And then you could do the whole little conversion thing here, where you put milliliters on bottom and 1 liter on top. Or you could do something else that's a lot easier. Just move your decimal over 3 places.
So it's 3.
So, right here, if you're going from milliliters to liters, you're going to go this way.
2, 3.
No.
No.
No. Oh. So you should get .365 liters. Can you do that with every problem? Just for volume, because you're either going to have liters and milliliters. And so it really depends on what they want. I'll tell you, most of the time, they'll want it in liters. And it's okay. If they don't specify, and this is actually a good question, or a good point, because y'all are going to ask this here in a second. I was like, well, what volume do I put it in? They didn't tell me which one. If they don't tell you what volume to put in or what unit, you pick whatever you want. They didn't specify. A volume is a volume. But it's like if I just said, what is the volume? And just cut out the in liters part, you can put it whatever unit you want, as long as it's a volume and it's correct. All right, so we got to talk about Charles. Not worry about the history of it. So anyway, we glanced at this one yesterday. You'll notice their formula is different. Two things. One, volume is still there. But instead of multiplying, you're dividing. Okay? Now, I will tell you there's an alternative formula where they skip a step. They go ahead and cross multiply and rewrite the formula, where they do like V1 times T2 and V2 times T1, and you just plug in from there. I'm going to recommend you not do that. I'm going to recommend you plug it in this formula, this one right here. The formula sheet I'm going to give you is going to have both on there, but I'm going to recommend this. Here's the reason why. Students do a small, simple mistake where they don't know what their V1 and V2 and T1 and T2 is when they plug it in, and they mess up on that formula. So I say this. I like this formula because it tells you before and after, and that's it. You can then do the math later on, but that's just me. You know, you might be a little bit more, entwined with what you do. I'm going to tell you to use that formula. Okie dokie.
Are you?
Oh, by the way, these all work out the same way. There's only one change, though. We have not done anything with temperature yet. But I did tell you there's only one unit you can have temperature in this unit.
Kelvin.
Kelvin. And how do you convert to Kelvin?
273.
I add 273. If it's already in K, leave it alone. But if it's not in K, add 273. Will I give you a Fahrenheit and say convert from Fahrenheit to Celsius to Kelvin? No.
Yes.
Probably.
No, I won't.
Yes, you will.
I swear. I promise. Oh, sorry. So anyway, basically Charles' law is this. Unlike Boyle's, where it's inversely proportional,
They both increase.
they are directly proportional, which means one goes up, the other goes up. And I'm going to show you that little law here in a little bit. It's very straightforward. By the way, if you haven't noticed the difference in their formulas, Boyle's is, P1, V1 gives you P2, V2. And this guy is V1, T1 gives you V2, T2. Okay? This one's inverse, and this one's direct. I probably should have flipped them. What do you notice about how the formula is set up versus the direct and indirect?
Well, V1 does equal V2. So,
Well, notice the setup here.
yeah.
If you see two fractions, that's direct. In other words, that's a ratio. Okay? This is an inverse ratio.
What? Oh, they swapped it around on us.
Yeah, what I'm trying to tell you is if you see a formula where it's straight across like this, where they're multiplying by each other, that's an inverse proportion.
Okay.
If you see one that's like this, and I'll jump ahead to Gay Lussig's real fast. Don't make fun of his name. Jesus Christ. We'll come back to these. There's Gay Lussig's. Without looking at this, you can still see it on my chest. Look at the formula. Tell me if that's direct or indirect.
Direct.
It's direct.
Because they go straight across.
No, well, they don't go straight across. They do a fraction kind of thing. So here's the thing. I don't know if you figured this out in your math class, because this is a concept you should know, or you should figure out. Anytime you see a formula where there's a fraction involved, they're directly proportional. Okay? When y'all were doing the little crisscross conversions, you're doing direct proportions. All right, so let's talk about Charles' law. So directly proportional, which is not going to be inverse. Okay? If temperature increases, what's going to happen to the volume? Going to go up or go down?
Up.
Hopefully you said up. Because that does make sense. If you increase the temperature inside a balloon, it's going to go up. All right? And then if you decrease the temperature, it's going to go down. It's going to deflate. So here's that little GIF again. Here we go. So pressure, if you notice, is being kept constant. 1.5 and 1.5. It did not change. Okay? So let's use our formula here. All right? So let's take a look at our temperature. What's it at?
250.
All right, so T1, V1 here. And then we'll do V2, T2. Okay? All right, so our temperature's at what, 250? Okay. What's our volume at?
2.5.
Yeah, look, it's kind of weird, and I'm glad y'all actually figured it out. Right here's where the line is.
Yeah.
It's like, well, it's 2 and it's kind of 3. It's actually 2.5.
Yeah.
Liters. Okay. So let's watch what happens as we increase the temperature. So we increase the temperature to 450. Okay, where'd the volume go up to?
4.5.
4.5.
Is that a coincidence?
I don't know. Let's find out. So how does this law work? If you plug this into this side and this into this side, they should be equal to each other.
Just 2 of them.
And if they are, the law works. Plug it in. See what happens.
2.
2.5 over 250 is equal to 4.5 over 450. So, by the way, just a quick refresher, how would you solve for all these? You could just go ahead and divide, but you could also cross multiply, but it doesn't really matter. Go ahead and divide these two. See what you get. You're going to decimal.
You make things so much more difficult than they have.
Right, they're the same.
0.001. No.
0.01.
Gosh, Tasha.
Okay, and I'm assuming this is 0.01, right?
Yes.
Yeah, they're the same.
There you go. Ratios are the same, which means you could remove one guy and solve for the missing variable. So how would you solve for this before we actually get into actually doing the real math? The easiest way is to cross multiply and divide. If y'all remember that, you're going to be fine on this part. So, you already said it. As temperature increases, what happens? The volume?
Increase.
It's going to increase also. Increase. Also, what happens to temperature as it decreases? The volume is going to decrease too. They're directly proportional. Again, I already told you, Boyle's law is the only one that's inverse. Any other law I give you from here on out, it's going to be directly proportional, which means one goes up, the other goes up. Okay? The more you work in your job, the more money you're going to get paid. And also, the more money you get paid, the more taxes are going to be taken out.
More tax you can pay on, the more hair in that blow out.
That's a good one. So a sample of argon occupies a volume at 88 milliliters. All right, let's say that's our V1. Why not? At 350. That's going to be, is that our P?
Yeah.
No, it's a T. We'll say it's our T1. If this was your V1, that has to be your T1. Okay? They say at.
Okay.
Okay? You could say V2 and T2. Just the other guy's going to have to be the other guy. It doesn't matter. As long as they're on the same side, the formula will work. What will the volume be, V2, if it occupies at 800 K?
So let's go ahead and drop 88 over 350K.
All right.
Come on, man, work with me.
88 milliliters.
350K. Alright.
350.
I'm going to throw an equal sign. I'm going to put an X on top yonder.
All right, we'll do X.
800K on bottom. I'm going to cross multiply and divide.
Now, y'all do know the formula, right? V1, for you, if you can't understand his accent.
Plain and simple. We learned this back in 6th grade.
There you go. Really?
I've been done.
Are you just mocking me?
I've been done learned
That's
this.
201.14.
So, in the end, you should have 88 times 800 divided by 350.
I ain't doing
201.
I did the whole problem. Y'all can do the math.
0.14.
That seems legit.
They learned me this
201?
2 years ago.
Yes.
Now, hold on. What's our units going to be in the volume?
We're going to be looking at milliliters.
If it was milliliters here, it's automatically there. Did they want it in another volume?
No, they would have stated it.
No, they would have stated it. So just keep it in milliliters. Hey, look at it. Glance at this real fast. Temperature was at 350 and at a volume of 88 milliliters. It increased to 800. Did the volume also increase?
Yeah.
All right, so what would the volume be? Okay, volume. So we got to figure out this guy. Let's say that's our V1. Okay. Of a gas at 82 Celsius. Okay. Now, they said volume at. These two are linked. So we're going to have to keep them either V1, V2. I'm sorry, V1, T1 or V2, T2. I got to say it right. It's volume at, okay. So what will happen if, what will it be if you move it to this temperature? So let's say that's our T2. And then this volume, V2. Okay. So here's the issue right off the bat. You cannot plug in 82 and 0.
Yeah, 273.
You got to turn those temperatures into K if they're not already. So last question, they were already in K for you. But this time they didn't. So to convert to K, it's whatever your Celsius plus 273. Technically, it's supposed to be 273.15, but you know what? Who cares? All right, so 82. I'm going to list these out to the side since you got to do a little extra work here. So V1. T1 was 82. Okay, so we need to add 273 to it to make it K. What is that going to be? 350?
Yeah, that's what we're looking at.
350?
Yeah.
55. Thank you. These are the units you're going to use. By the way, look real quick. Did they say they want volume in a specific unit? No. So whatever you get is going to be in liters.
What was the 1 ATM there for?
Oh, 1 ATM. What about it?
It's just there?
Yeah, it's to throw you off.
That's not cool.
Did they say anything about the pressure changing?
No.
It's not. Remember, that only you're going to take that consideration if they change the pressure also. But they didn't. So you'll see questions where they'll throw in a unit, but you might not use it if it doesn't change. So always look, did it change? If it didn't change, it's not a factor. Okay? Does that make sense? Clear as mud? All right. Oh, by the way, let's plug her in. So V1 on top, yeah, you got to have 355 on bottom, set it equal to over 857 and 273. Volume was at 8.5 and at a lower temperature. Temperature increased. What happened to volume? Increased. I keep telling y'all that because questions on the test are not just going to be math. It's going to be things like if the temperature increases, what happens to volume? You know, things like that. So you can't just do math. You got to actually think of how these laws work. But that's the only curveball I can throw you is actually throwing another unit that you're not going to use. Oh well. All right, so Gay-Lussac's law. So this guy, don't worry about too much. We don't really go too much into his law. The reason why is because he kind of just built upon the other two guys. The other two guys did the research, and he was like, well, if this guy did this and this guy did this, I'm going to make my law. And so that's where his come in. So we don't go too much into it. And I'm not going to go too much into it either because the same rules apply with both of those other laws. We just remove volume and just do pressure and temperature. So guess what? When you use this formula, just remember pressure has to, and both pressures have to be in the same unit. And both temperatures, what unit they have to be in?
Kelvin.
Got to be in Kelvin. And some of y'all learned that last night or yesterday as y'all are plugging everything into the formulas. They got to be in K. Okay, you don't have a choice. But notice if we keep volume constant, we could see this going on. So anyway, so real quick, this is not going to take long. I'm not going to go over too much of the practice here, but you do note that these guys are directly proportional. Pressure's got to be the same unit. Temperature has to be in Kelvin. All right, so what's going on is this. As the temperature went down, the pressure inside also is going to go
Up,
well, nope, you're reading the first one. I said the bottom one.
down.
I messed with you. So the temperature went down. So the pressure is going to go down. As the temperature increases, though, the pressure is going to increase inside. So that's what she did. She got the pressure built up inside, then she kept it off. Okay, so the pressure was locked in. And then, as she put it in the ice bath and had to spray it with a water hose, ooh, let's see. Determine the pressure change of a constant volume of a gas at 1 atm is heated from.
P2.
So originally the pressure was 1, right?
So it is P1. That's what I said.
There you go. Determine the pressure change. The pressure change would be then the final guy. Okay? So this is your P1. Got to be careful because they did this one on there was one on your homework last night that said if you went from, I think it was a temperature one, it went from this temperature to this temperature, you got to be careful. So this is going to be a P1 because you're starting here. Most of the time it's going to be your first one. So determine the pressure change when the constant volume of a gas, that need to be reworded a little bit. Anyway, so we just plug and chug, right?
That is correct.
Okay, so let's do it. But what do we got to do to these two guys? Do I need to list them out to the side?
No.
Okay, so what is this in K? 293 K. And what is this in, obviously 10 more up, 303. So let's plug her in and see what we got.
1.03.
Do we need to convert our ATM?
No.
No. Did they want it in a certain pressure?
No.
No. Joe, just plug or chug. So, all right, cross multiplied, you got this, divided into that. X is going to equal what?
1.03 ATM.
Now let's look. Did the temperature go up?
Yes.
Did the pressure go up? It did, very little, but also the temperature went up very little. So that's how this works. Let's see, okay, so let's now read it. All right, a gas has a pressure of da-da-da at this, all right? So I guess this is listed first. P1, T1. What is the temperature at standard pressure? Okay, so I guess this is going to be our, oh, sorry, I forgot my G. Our P2. And so I guess we got to figure out our T2. What'd you get?
340.31 Kelvin.
340.31. Seems legit. We're not going to go too much into it. But do you know when they had all the robots, they come together to make a bigger one?
Yeah.
Okay, same thing about the laws. We had Boyle's law, okay? Then we had Charles' law. And then we just added Gay-Lussac's law. So guess what happens when we put all these together?
We get
They
the
go
gold
combined gas law.
You get the combined gas law. You need to write that down.
Oh gosh.
So, by the way, I will give you a trick. You're probably going to forget this trick anyway. Technically, you could just use the combined gas law on all problems and get it right.
Hey, it's already on here, silly Billy.
Good. So, but you got it?
Got it.
All right. We'll talk about it more when it comes back. It has all laws in there.
Go, go, Power Rangers.